Okay, this is the P4 paper from June 2024. It's question number 9, which is the last question on the paper, and it looks a bit scary, doesn't it, with this function right here. What we're going to be doing is integrating. We're going to be finding a volume of revolution. The integration is going to take place by substitution, and we'll even have a little bit of implicit differentiation in there when we get going with it. But let's have a read through of it. As I say, really scary looking question. So it says region R is shown in that diagram there, and what we're then going to have is this region is rotated about the x-axis to produce this volume of revolution here, and the volume of revolution is always given by the integral of pi y squared dx, and in fact we've even got the limits there between 3 and a third, but y is that thing there, so squaring that is not going to be very easy, and then trying to sort out the integration of that is certainly not simple, but let's at least make a start to it. So let's tell the examiner what we're doing. We're saying volume is equal to the integral of pi y squared dx between 3 and a third, and I think I'm straight away going to say, okay, what's y squared going to be? Well, y is equal to the x to the minus a quarter, all divided by the square root of 1 plus x, and then arctan square root of x. So yeah, not the simplest of things to look at. So if that's y, then y squared is going to be all of that squared. Okay, so if you square x to the minus a quarter, that's going to give us x to the minus a half. Add the powers. The square of root 1 plus x, well, at least that bit's getting a little bit easier. That's becoming 1 plus x. But then we've got all that bit in the brackets, arctan square root of x. That is all going to be squared. Okay, so my volume is going to be then, is going to be the integral, again, between 3 and a third of pi y squared. Well, let's at least take the pi out to make it slightly easier for myself. Y squared dx then is going to be what we just had, x to the minus half all over 1 plus x arctan root x squared dx. Okay, but at least they tell me what to do. They say use the substitution, tan u is equal to root x. So substitution, tan u is equal to root x. So if we look at this function, then the first thing I'm going to do over here is say if tan u is equal to root x, then u is going to equal to arctan, tan to the minus 1 of root x there. So at least if we're looking, I've got that bit sorted out. That's going to be u. There's going to be 1 over u squared. Okay, so we're up and running. My issue is going to be, as always with the substitution, sorting out the dx. So I'm going to sort that out first before I try and do anything else. And this is not the easiest of substitutions here, so I'm just going to differentiate both sides with respect to x. So if I'm differentiating tan u, but differentiating it implicitly, the differential of tan is sec squared u, but it's sec squared u du by dx. And then differentiating x square root, or x to the half, is multiplied by the power, take 1 off the power, so we get that as being my sec squared u du by dx is equal to, what I'm going to do is I'm going to get dx here, and I'm going to replace this dx with that. There's other ways of doing this, but I think this is probably the easiest way if I'm trying to explain it to people. I'm going to say dx up there then will be sec squared u du all divided by half x to the minus a half. Okay, so that is going to take care of quite a bit of this stuff in here. The thing it won't take care of is the 1 plus x, up there, the 1 plus x. I won't be able to sort that out, so we may as well do that at the same time here. So if tan u is equal to root x, then tan squared u is equal to x. I'm just coming from that straight down to there. So just get rid of that. Tan squared u is equal to that. And then I want to try and get sec squared u, don't know, because I've got a sec squared u in my dx there. So I know that 1 plus x is going to give me 1 plus tan squared. Actually, I'll probably do it on a separate line just for the examiner. So that's true. I know I've got to get 1 plus x. So 1 plus x is 1 plus tan squared u. And then that's really helpful because 1 plus x then becomes sec squared u. So not easy, this one, but, you know, it's question 9, so it's fair enough. You've got to have all your wits about you with all your different topics and like trig identities. You've got to be able to do those. Now, before I do the substitution, the one other thing I want to do is just sort out these two limits, because that won't be too difficult to do. So I'm going to just do this here, but explain to the examiner what I'm doing. So for my limits, if x equals 3, then tan u is equal to root x, so tan u is equal to root 3. So u, tan to the minus 1 of that is going to be pi over 3. And then the same if x is equal to a third, I'm going to get tan u equals 1 over root 3, which will give me u working out to be equal to pi over 6. So as I'm trying to go through now and sort all these things out, let's just put in that my volume is then going to be equal to pi. So the limits are going to change. The limits are now going to be pi over 3 and pi over 6. And all I'm going to do, I'm just going to write down, well, I've got x to the minus a half all over. Now, it's up to you what you want to do here. So I can replace this one and I can replace it, sorry, up here. I can replace that with 1 plus x, and I can replace arctan that with my u here. So I'm just going to do those two bits first of all and leave everything else as it is. So 1 plus x is going to be sec squared u, and arctan root x is u squared. And then I'm going to replace my dx. I'm going to replace my dx with all of that. And when I do that, it will just take care of that x to the minus a half, you see. So dx is sec squared u du all over half x to the minus a half, because then we can see that that's going to cancel with that and that's going to cancel with that. So this is all going to get very, very simple in a minute. I'm not going to take all those out. I'm just showing you what's going to happen. If you want to for the examiner, you can put a light through there and a light one through there, a light one through there, and a light one through there. But just be careful as we're tidying this all up then. So that's going to give me pi over 3, pi over 6. Let's say the sec squared goes, what do we get? We'll get 1 over 2 u squared, because that half hasn't gone anywhere. 1 over 2 u squared du. Sorry, 1 over half. Yeah, be careful. That's what I said, be careful there. 1 over a half there, because then dividing by a half is the same as timesing by 2. So I'm going to say 2 pi. Pi over 3, pi over 6, 1 over u squared du. And if we now go back, I didn't really take too much of a look at that because I've done this question before. I couldn't do this without at least having a practice of it. So I knew what I was aiming to get towards there, and we've got to the stage where we've worked out what k is for that part. So part A there, not easy, definitely not easy, but as I say, last question, and certainly you should be able to pick up some marks for this by going through, doing all your parts to it. And then part B simply says, let's just go back and have a look at it, but just says, right, find the answer. So find the answer means actually carry out that integral then. So the volume is equal to, This is 2 pi integral pi over 3 pi over 6 u to the minus 2 du. So add 1 onto the power, divide by the new power. That becomes minus u to the minus 1. 2 pi between pi over 3 and pi over 6. So if you then put that in, that's 2 pi, and that then becomes minus 3 over pi, minus, and then it's going to be minus 6 over pi. And then if you tidy all that, you can work that out for yourself, but the pi's cancel. We actually get that really neatly working out to be equal to 6 there. So find the value in its simplest form. 6, so that is in its simplest form. Yeah, not a very easy question at all, but fair enough. You know, it's the last question. So hopefully it makes sense now. I've explained it to you. You might need to read that through a couple of times.